Okay, hello class. Uh, Welcome to our first video lecture. The subject that we are going to be learning this semester is called as the numerical methods, and as the name suggests, it's going to be a very much mathematical kind of subject. Can seem a bit like M4, although there are certain differences. It's definitely a mathematical subject, but certain differences with M1, M2, and M3. If you remember correctly, in M1, M2, M3, what we used to have was most of the problems were based on some kind of theorems or some kind of methods in differentiation or integration, something like that. Solve this, prove that. Here you will not have that. What we're going to have in numerical methods are more down to earth, or you can say close to practical applications kind of problems, where you will have to actually find out the solutions for practical problems rather than just going into abstract. Okay, let me give you an example of what numerical methods are actually used for. There are certain methods like analytical methods. For example, factorization of a quadratic equation. Let me take an example. X square minus 2x plus 1 is equal to 0. As you can very well see, and most of you would have guessed, this is nothing but if we x square minus x plus 1, so x into bracket x minus 1 into bracket x minus 1, right? This is equal to 0. So which means that x minus 1 into x minus 1 is equal to 0. X minus 1 is equal to 0, which means that x is equal to 1. Very easy kind of solution, right? This is a quadratic equation. So this can be easily solved using the analytical methods. But suppose the equation goes something like this. Right? If you can very well observe that mostly this kind of equation cannot be solved using any of the analytical methods that we have learned so far, right? So what we have to do here is that we have to use some kind of numerical method or iterative method, maybe to get the actual value of x here that satisfies this equation, that makes this equation continuous one. So this is what the numerical methods is about. Most of the transcendental equations or equations that are applicable in real life scenarios, they cannot be solved using these analytical methods. So for them, these numerical methods have been developed. There have been many of the numerical methods. I think we have around 18 or 20 different types of methods that we're going to learn this semester. Okay, so without any further ado, I'm going to start with our first method. It's a very basic of the methods. This is called as the bisection method. Okay, as the name suggests, bisection, which means that division into two. So whatever interval that we are going to have, we are going to divide it in two halves and see where that equation or that solution lies, something like that. Let me show you how we are going to do that. Okay, x-axis, y-axis, reverse in fact. Okay, x and y, or we are going to call this axis as fx, the value of fx. Okay, all right. Suppose each and every equation has a curve. Suppose this equation x sin x minus 1 is equal to 0, whatever it may be, it has a curve. Suppose it's something like this. Alright, so as you may well have guessed, this solution, this equation can always have more than one roots, right? So basically what bisection method does is it finds out one root within one bracket, right? Okay, suppose, just let me get this. If an equation has a kind of cyclic function, it can very well have a curve that looks something like this. right? So basically there are many instances at which this curve touches the 0 mark, where this equation fx is equal to 0. There are many values of x where this happens, right? So each of these lies between a bracket. Okay, so basically what bisection method does is it finds out a solution within a bracket, right? Suppose we take two values of x, say a and b. All right, so if we just kind of this is b, this is a. Okay, as we can very well see, the value of fx when x is equal to a, that is somewhere around here, which means that that value is a positive value. And here, if you can notice this point, the value of fx lies below 0, so this is nothing but a negative value, right? So basically what we can assume when we see one point getting a positive value and one point getting a negative value is that there has to be one point in between them at which the value of fx will be 0. So what we have to do is we have to find out the value of x such that between a and b, where value of fx is 0, right? So that is going to be our solution. So what we are going to do here is that we'll just go on bisecting this bracket by half. All right, this is called a bracketing method because it finds out the value between a bracket or between a limited interval, that is a to b, right? So our first iteration is going to be x1, which will be equal to a plus b divided by 2. Okay, so basically it will lie somewhere around here. Okay, so what we'll do is we'll calculate this and then find out what the value of fx1 is going to be. When x is equal to x1, what is the value of this function or any other function? All right, fx1. Suppose we just take this curve into example. If we drop a line, a perpendicular on the axis there, we can see it's here, so which means that fx is still less than 0, right? So now our new bracket becomes a and x1, right? Got it? A and x1, that becomes our new bracket. So again we are going to follow the same method. So our next iteration is going to be x2, which is nothing but a plus x1 divided by 2. Okay, a plus x1 divided by 2 will again find out the value of x2, what the value of fx2 is going to be. As we can see, it will lie somewhere around here. Again, if we drop a perpendicular on the x-axis, this is somewhere that this is going to lie. Take a look at this one. So as we can see, the value here is a positive at x2, right? So x2 is positive and x1 is negative. So our new bracket, a much smaller bracket, is going to be x2 to x1, right? So the third iteration, x3, will be x1 plus x2 divided by 2. All right, again we'll find out what fx3 is going to be. Okay, and then continue this method on and on and on until we reach a point, say fxn, which will be 0. Okay, so here we can say that we have reached the actual solution. Although I know that this process seems a bit long, there are many iterations required to find out the actual root of the equation, but let's not forget that this was one of the earliest methods. We can say it was one of the first methods, numerical methods. So although it takes a long time, it gives you very accurate results, and has been used for many years. So to know the basics, we have to know this. Okay, usually what happens in exam is they give you the number of iterations that you have to do. Suppose they will say find out the root until you have reached, say, 4 iterations, okay, or 5 iterations, something like that. And most of the times this bracket, this a and b, these values will be given to you. They will say that find out the root between a and b, between 2 and 3, something like that. Okay, find out the root of this equation between 2 and 3 up to 5 iterations. So that's how most of the questions on this method fall. Let me show you a question paper, an actual exam paper. Okay, if you can see here, find the positive real root of x log x to the base 10 is equal to 1.2, which lies between 2 and 3 using the bisection method in 4 iterations. Okay, so as you can see here, the number of iterations is given and 2 and 3 is given. Okay, positive real root and everything, don't worry about that. Between 2 and 3, it's going to be a positive root. We're not going to worry about the imaginary roots of this. Okay, so basically what we have to do is convert this into an equation and then go on solving it, right? So suppose if this bracket is not given in the exam, or the number of iterations is not given, then what you will do is maybe go on using the arbitrary values. Say start with 1, what f of 1 is going to be, what f of 2 is going to be, 3, and go on finding out the values of fx. So as soon as you reach one positive value and one negative value, stop, take that as the bracket and then continue. Alright, so and if the number of iterations is not given, I would say it's ideal to go up to, say, 10 iterations, and that should give you plenty of marks. Alright, to do that, what I recommend is use a calculator. Can everyone see this? Okay, I hope so. This is an FX82MS, 82MS or 82ES. Any of the 82 series is okay. They are not programmable. And as you can see, suppose it's a cubic equation, then say it lies between 2 and 3. Suppose it's 2.225. Okay, so suppose this was my equation, x cube minus 4x minus 9 is equal to 0, and the value of x that I want to find out the value for is 2.225, right? So I'll just get this value, say what is this, minus 6.8849. Okay, suppose the next iteration I find out it's something like 2.375. Then what I can do is just change the value here and get the next iteration. It's still negative. So by just using the cursor keys and changing the values, you can get the next iteration, and it takes hardly around 20 seconds, 30 seconds. So my recommendation is this: definitely decide what kind of calculator you are going to use, purchase that one and stick with that one. Okay, know each and every of its functions, keys by heart. Just use it in each and every of your lectures and you should be fine. Okay, so that is my recommendation for this. Alright, now what we'll do is we'll take an actual problem and try and see what happens. Okay, let's take the same one that I just told you on the calculator. Okay, solve x cube minus 4x minus 9 is equal to 0 until 5 iterations using bisection method. Okay, this is a problem from an actual exam paper. Alright, as you can see here, the number of iterations is given, that is 5, but the let's see, the bracket in between which you have to find the root is not given. So alright, what we'll do is just write down fx is nothing but x cube minus 4x minus 9 This is the equation that we have to solve. Alright, we'll find out what happens when f is equal to, when x is equal to 1, right? 1 cube minus 4 into 1 minus 9, and if you calculate this, this comes around between minus 12, right? So this is a negative value. Let's see what happens when x is equal to 2. Alright, so 2 cube minus 4 into 2 minus 9, this is 2 cube, that is 8, minus 8, so that's 0, minus 9, right? So still negative, we have to go further. Let's see what happens when x is equal to 3. 3 cube minus 4 into 3 minus 9. 3 cube is 27, minus 4 into 3 is 12. 27 minus 12 is 15, minus 9, so plus 6, right? We have our first sign change. When x was equal to 2, fx was minus 9. When x became 3, fx became plus 6, right? So first sign change, which means that our bracket is going to be this 2 to 3, right? So what we have to do is we have to find out a root of this equation between 2 to 3 until we have done 5 iterations, right? Okay, so let us see what our first iteration is going to be. x1 is equal to 2 plus 3 divided by 2, which is nothing but 2.5. Alright, let's find out what f of x1 is going to be. Okay, so just for the sake of the later iterations, let me put it like 2.5000, okay, cube minus 4 into bracket 2.5000 minus 9. Okay, so as you can see, it's minus 3.375, right? It's still a negative value, which means that our next iteration is going to lie between x1 and b, which is 3, right? So our next iteration, this will be our first. The second iteration, x2 is nothing but 2.5 plus 3 divided by 2. Okay, it's nothing but 2.75. Let's find out what f of x2 is going to be. Okay, as you can see on the calculator, I'm just gonna change these two digits, nothing else. Okay, 0.7969 positive value, right? So which means that our root is going to lie between x2 and x1, right? So x3 is going to be 2.5 plus 2.75 divided by 2, which is nothing but 2.625. Okay, as you can see, as we go on increasing the number of iterations, these significant digits here it was just 1, 2.5, here it became 2, 2.75, here it became 3, 2.625, which is why you will understand that I put down, instead of just writing 2.5, I put down 2.5000, so it will be helpful here. That's why I did this. Okay, let's see what happens now. 2.625 minus 4 into bracket 2.625. Alright, let's see what happens. Okay, so f of x3 is minus 1.4121. Okay, so this is a negative and this is a positive, which means that our next iteration is going to lie, our next root is going to lie between x3 and x2, right? So fourth iteration, x4 is equal to 2.625 plus 2.75 divided by 2, which is 2.6875. all right, now let me 2.6875 I'm sorry, 6875 cube minus 4 into bracket 2.6875 minus 9. Okay, so f of x4 is minus 0.3391, which is less than 0, which means that the value will lie between this one 2.6875 and the last positive value that we had, which was 2.75, right? So our root is going to lie between 2.6875 and 2.75, so which is going to be our fifth iteration. x5 is going to be 2.6875 plus 2.75 divided by 2, which is 2.7188. Alright, as you can see, what we had to do was we had to calculate the root until we reached 5 iterations, and what we have reached is this is the fifth iteration. If they ask you for 5 iterations, you just have to calculate the x5, which is this one. This is the value that we have calculated for fifth iteration. This is the root after 5 iterations, so we can just stop here. Okay, this will be your answer. This will be your answer, 2.7188. After 5 iterations, the root of the equation that we find out is this. Okay, you don't have to calculate the f of x5, which means that the value of fx at x5. We just have to do that if we want to go further and go for the sixth iteration. Okay, we don't have to do that here, so which means that we have reached the conclusion. This will be your answer. Okay, now let us take into consideration one more. Let me just go through. Until I do that, please remember that the reference book that I'm going to... Okay, I'm sorry about the disturbance. As I was telling you, the book that I'm going to recommend for this semester is this one, Numerical Methods in Engineering and Science by Dr. B.S. Grewal. This includes the program in C and C++, which is an added advantage. It is a book by Khanna Publishers. Okay, so if you want to purchase it or get it from the library, I would recommend this one. It has almost all the methods that we are going to need this semester. Okay, all right. So let's get on with our second problem. Okay, it says using the bisection method, find an approximate root of the equation. The equation that they have given here is sin x is equal to 1 by x between x is equal to 1 and x is equal to 1.5. Okay, here they have given a note that x is measured in radians. Okay, all right, and always remember, if the unless the example that you have given the numerical, it says that the angle is given in degrees, always assume that the angle that you have been given has been measured in radians. Okay, please remember that. Okay, and it also says that we have to carry out the iterations until the 7th stage. Okay, so they have given the bracket, that is x is equal to 1 to x is equal to 1.5. The number of iterations is given as 7. Okay, x is measured in the radians, and this is our function. Okay, all right, so let's continue. It says sin x is equal to 1 by x. Okay, so what we're going to do is multiply both the sides by x, so x sin x is equal to 1, which means that x sin x minus 1 is equal to 0, which is focus. Oh, yeah. Okay, it's nothing but the first solution that we looked at. X sin x minus 1 is equal to 0. All right, for those who do not know, 1 radian is equal to 57.3 degrees. You can use this to go from 1 to 1.5, or what you can do is just multiply it by 57.3, or what you can do is set your calculator in the radians mode. Alright, okay, as you can see on the top row of your keys, there is one key which is called as mode. If I press this, it says comp SD reg. If I press it again, it says degrees, radians and greater radians. Here it's mode number 2, so I have selected that, and it won't be clearly visible, but here it says it's there is a small square which says R, which means that the mode we have gone is the radians mode. Alright, remember this one, in mode go for the radians. Okay, alright, so let me see. We have to go until the 7th stage. Let's begin with our first approximation, x1, which is nothing but 1 plus 1.5. Oh, I'm sorry. Before we do this, we have to find out what f of x is equal to 1 is going to be. Alright, so 1.0, again I would suggest go for 1.0000 multiplied by sine of 1.000, okay, minus 1. Okay, got this? Let's get this. Okay, so this is nothing but minus 0.1585. okay, everyone got this? Okay, so this is a negative, and let's see what happens when fx when x is equal to 1.5. okay, alright, so just going to put 1.5 here and 1.5 here. Alright, so this is 0.4962. so this is a positive. A sign change has occurred, which means that there is definitely a root that lies between 1 and 1.5. Alright, okay, so let's continue with this one. x1, the first iteration, is going to be 1 plus 1.5 divided by 2, okay, which is nothing but 1.25. okay, let me see what happens when we put 1.25 in this equation. Okay, it gives a positive value. F of x1 is equal to 0.1862. alright, so next iteration, this is going to lie between x1 and 1. okay, so x2 is nothing but 1 plus 1.25 divided by 2, which is 1.125. okay, so I'm going to put this here, 1.125, 1.12. 0.125. So as you can see, this one, f of x2, gives me a positive value again, which is 0.0151. okay, which means that our next iteration is going to lie between 1 and x2. so x3 is going to be 1 plus 1.125 divided by 2, which is nothing but 1.0625. okay, let's see what happens at fx3. 1.0625 sine of 0625 minus 1. okay, this becomes minus 0.0718. okay, which is negative, which means that, look at that, okay, yeah, alright, 0.0718, which means that x4 is going to lie between x3 and x2, right? So 1.0625 and 1.125. so x4 is going to be 1.0625 plus 1.125 divided by 2. okay, alright, 1.0625 plus 1.125 125 divided by 2. Okay, so everyone can see that. All right, let's just check again. It's always useful when you go for higher iterations to check once again. 1.0625 plus 1.1250 divided by 2. Okay, got the same thing. So 1.0938 is going to be our fourth iteration. Let's see what happens at f of x4. Okay, 1.0938 into sine of 1.0938 minus 1. Okay, this gives me a negative value of 0.0283, right? So which means that again our next iteration is going to lie between x4, which is 1.0938, and x2, the last positive value that we had, which was 1.125. okay, all right, so let's go for fifth iteration, x5, which is 1.0938 plus 1.125 divided by 2. Okay, let's see what that's going to be. Okay, 1.0938 plus 1.125 divided by 2. Okay, which is 1.1094. Okay, everyone got that? All right, f of x5 is going to be 1.1094 into sine of 1.1094 minus 1, nothing but minus 0.00. Let me show you this one, minus 0.0066, right, which is a negative value, which means that our sixth iteration is going to lie between 1.1094 and the last positive value, which was 1.125. okay, so x6 is going to be 1.1094 plus 1.125 divided by 2, right, which is going to be 1.094 plus 1.125 divided by 2. Point 1094 plus 1.125 divided by 2, okay, which was 1.1172. all right, okay, so let's see what happens at f of x6. 1.1172 multiplied by sine of 1.1172 minus 1. This gives you a positive value, 0.0042. okay, so as we can see, we have reached the positive value for x6, which means that for the seventh iteration, the x7 is going to lie between this value, which is 1.1172, which was the last positive iteration, and the last negative iteration, which means that x5, which was this one, which is this 1.1094. so x7 is going to be nothing but 1.1172 plus 1.1094 divided by 2, which is equal to, let me get my calculator here, 1.1172 plus 1.1094, okay, divided by 2. It's nothing but 1.1133, right? So this is our seventh and final iteration. As I told you earlier, if the problem or the numerical that they have given you says that you have to solve it up to seventh iteration, then you don't have to continue. Okay, so we don't need to find out what fx7 was. As far as we are concerned, for this problem, the final answer is this. Okay, so this is going to be the last problem in this video, and I hope that with these two practice problems and whatever problems that we are going to solve in our class, it should be sufficient to crack the bisection method. Okay, so make good use of these videos. Refer to them anytime you like, even at the time of your exams. This should be useful, and I hope that this new method that we are employing for this year will be helpful. Okay, so best of luck, and don't forget to bring your calculators when you come to class.